Tonight, I want you to treat the sun like a chart you can't close. Not Bitcoin, not stocks, space weather, because right now there's a monster sunspot, AR4366, and it's doing that thing where calm turns to chaos. Most people hear solar flare and they imagine pretty auroras. Cute. But the real game is invisible. Your radio, your GPS, your satellites, your flight routes, your power grids, systems so normal you only notice them when they glitch. So here's the hook. What if I told you the sun is basically running a psychological experiment on Earth, and the people who feel safe are the first to get blindsided, because they don't understand the difference between noise, signal, and a setup? I'm not here to give you a boring lecture. I'm here to make you feel the suspense in the data, because once you see how space weather forecasters think, you'll never look at a quiet sky the same way again. Picture this. You open NOAA's Space Weather Prediction Center page like it's a trading terminal. You don't need a telescope to feel the danger. You just need one line: current space weather conditions. And then the part that hits different: radio blackouts. Now, R1 sounds harmless, like level 1 in a video game. Minor, easy. But this is where your brain gets strict. Minor makes you relax. Minor makes you scroll. Minor makes you ignore the next alert that escalates. NOAA's own wording is calm, almost polite. HF radio can degrade on the sunlit side. Occasional loss of contact. Navigation signals can degrade briefly. That's the official vibe. Quiet, clinical, dangerous. And then your mind does what it always does. It tries to turn that into a story you already understand. Like, okay, so Wi-Fi might be slow. That's the trap. Space weather doesn't care about your familiar metaphors, so let's weaponize curiosity. If AR4366 is the source, then what's the mechanism? What's the move? What's the next candle? Because the sun doesn't speak English, it speaks magnetism, plasma, and sudden bursts of radiation. Here's your first open loop. The scariest space weather events aren't always the biggest flares. Sometimes the biggest flare is loud but empty, and the smaller one is the thief that steals your normal day. Stay with me, I'll prove it. AR4366 rotated into view around January 30th, and it didn't arrive quietly. Space.com described it as so large, about 15 Earths wide, that with proper eye protection, you can actually see it as a dark blotch. That detail alone messes with your head, because you're used to thinking the sun is a smooth, perfect circle. Then you realize the perfect thing has scars, dark, angry regions where magnetic fields twist like cables under stress. Now your brain goes, if I can see it, it must be safe. Wrong again. The part you can see is the calm-looking bruise. The danger is the sudden snap, the moment the magnetic tension releases like a stretched rubber band. Space.com says AR4366 has already produced over 20 MI and X-class flares since it appeared, and those bursts have triggered radio blackouts when their radiation reaches Earth. That's not a vibe, that's a pattern. But here comes the plot twist that separates real watchers from headline surfers. Not every giant flare throws a coronal mass ejection at us, and the CME is usually the piece that sets off geomagnetic storms and bigger aurora shows. On NOAA SWPC's own news post about an impulsive X4.2 flare from region 4366, they said something that should make you lean in. No CME signatures have been identified in imagery at this time. Read that again slowly. Huge flare. Big number. Big letter. And still, possibly no CME, meaning the punch was loud, but maybe it wasn't the full combo. This is exactly why your intuition fails you in space weather. Now let's turn this into a thriller. Because the most dangerous character in a thriller is not the monster you can see, it's the monster you can't. In space weather, that invisible monster is Earth-directed plasma. And that's where NOAA's other update comes in. They posted about an X8.1 flare from region 4366 and noted modeling for associated CMEs, suggesting most material would pass by Earth, but with possible glancing influences. A glancing blow is the worst kind of suspense. It's not a clean hit, and it's not a clean miss. It's the kind of impact that makes your world feel off without screaming the reason, like a shadow passing over systems. So the question becomes, are we watching a loud sunspot that mostly barks, or are we watching the opening act before a heavier Earth-directed ejection decides to actually connect? Because AR4366 isn't done just because you got bored. NOAA's weekly activity story basically said, yes, region 4366 is complex and flaring from M1 up through X1 levels, but at that stage, there wasn't clear evidence of CMEs yet. Still, it's the one to watch. That one to watch line is your second open loop. It's like a warning in a horror movie when the camera lingers on the basement door. Nothing is happening. Yet. And you already know what that yet means. Here's the part I want you to feel. The sun is not being random. It's being physical. Magnetic fields wind up, stress builds, and releases happen. Your job isn't to predict perfectly, it's to understand the menu of outcomes. So let's mess with your expectations. When people hear space weather, they imagine only auroras, but the first effects can be mundane and mean. Radio signals disrupted, navigation degraded, and headaches for aviation and HF communication planning. Space.com reported that the X4.2 flare on February 4th disrupted radio communications across parts of Western Africa and Southern Europe. And again, they emphasized no CME signatures detected after that flare, citing NOAA SWPC. Now notice the psychology. If the flare causes a disruption, people notice and then forget. If it doesn't cause a disruption, people notice nothing and feel safe. Either way, the brain learns the wrong lesson because the system is larger than one flare. So let's play a game. I want you to imagine AR4366 as a boss with phases. Phase 1, attention. Phase 2, disruption. Phase 3, uncertainty. Phase 4, the moment you think it's over, then it throws the real move. And yes, radio blackouts is a scary phrase, but NOAA's scale is designed to communicate impact, not panic. R1 is minor, but minor doesn't mean ignore. It means watch for escalation and understand the context. Here's the pattern that keeps viewers watching. I'm going to give you 3 tells to look for, but I'll only reveal the 3rd tell near the end, because that 3rd tell is the one most people never learn. Tell number 1 is visibility. If the region is facing Earth, it matters more for near-term impacts. AR4366, being near the center of the solar disk, is basically the sun pointing the loud end toward us. Tell number 2 is repetition. One flare is drama, a barrage is pressure. When an active region keeps throwing M and X events, it signals stored magnetic energy and complexity, not just a one-off hiccup in the sun's atmosphere. Now, before your brain says, okay, so I'll just stare at alerts, I need to warn you. Doom-refreshing space weather can turn into anxiety content. The point is not to fear. The point is literacy, being able to translate alerts into reality. Let's talk about the most common misconception, because it kills retention when creators get it wrong. A solar flare is electromagnetic radiation that arrives quickly. A CME is plasma that travels slower. One can happen without the other. That's why you can see radio disruptions without getting a massive geomagnetic storm. It's also why aurora hype can disappoint. People expect fireworks immediately, but the real story is timing, direction, and whether the ejected material connects with Earth's magnetic field. Now I'm going to do the mind game. I want you to predict which is scarier, an X-class flare with no CME or a slower CME from a less dramatic flare that hits Earth dead on. Most people answer the wrong one. Because X-class is a status symbol, it's a headline magnet. It triggers your big number equals big danger reflex. But real impacts depend on geometry and magnetic orientation, especially how the solar wind's magnetic field interacts with Earth's. You don't need a PhD to understand this. Think of Earth's magnetosphere like a shield. Some hits glance off, some hits slide around, and some hits find a seam. The seam is when conditions allow energy to pour in. Now I'm going to pull you closer with a promise. By the end of this video, you'll know how to read the situation without becoming a doomer. You'll know what's likely, what's possible, and what's pure content farming. But first, let's talk about the reason AR4366 feels like it's everywhere. It's big enough to be a visual story and active enough to be a disruption story. That combination is rare, and it makes editors and algorithms happy. And it makes you, the viewer, feel like you're living in a special moment. That feeling is real, but it's also dangerous because it makes you overinterpret every headline. Space weather has bursts and lulls. The lull is not the end. So here's how we keep it real without killing the fun. We treat the sun like a living machine that has moods, cycles, and recurring patterns. We don't worship it, and we don't dismiss it. We watch it like professionals. NOAA SWPC exists for exactly this reason. Space weather isn't just astronomy content. It's operational. It affects aviation, GPS systems, satellites, and more. That's why they publish forecasts, summaries, and impact scales. Now, I want you to feel the cinematic scale. AR4366 is a dark patch on a star that's 93 million miles away, and yet its behavior can reach into your day. That is the most sci-fi real thing we all live with. But we're not done, because the next layer is the false calm. The flare happens. The news happens. Then 2 days later, the world feels normal again, so people stop paying attention. That's when you miss the long tail. A region can keep producing flares as it crosses the disk. It can also rotate out of view, then return about 27 days later. Space weather forecasting uses persistence and recurrence because the sun rotates and active regions can survive. So if you're watching AR4366, don't just watch today's spike. Watch the pattern. Watch whether it keeps firing as it moves across. Watch what NOAA says about expected activity in the coming days. Now comes the safety paragraph, but I'm going to deliver it like a friend, not a school poster. If you plan to look for AR4366, do not look at the sun with naked eyes or regular sunglasses. Use certified solar eclipse glasses. And don't let the "it's just a small blotch" idea fool you. The damage risk comes from sunlight itself, not the size of the spot. Your eyes don't have pain receptors for retinal burn in real time. You won't feel it until later. Okay, back to the story. Imagine you're an airline dispatcher, a ham radio operator, a GPS-dependent worker, or someone whose job quietly relies on stable signals. You don't need apocalypse, you need reliability. Space weather threatens reliability first. NOAA's R-scale language is built around that practical reality. Weak or minor degradation, occasional loss of contact, brief navigation degradation. That's not Hollywood, but it's enough to matter when you stack it across millions of users. Now I'm going to mess with your mind again. Your brain is addicted to visible consequences. It wants auroras, but the more likely early consequence is, why is my signal weird? And because it's subtle, it gets misattributed. People blame their router, their phone, their provider. They reboot, they rage. Meanwhile, a burst of solar radiation is literally changing Earth's upper atmosphere and its ability to carry certain radio frequencies. That's the hidden layer. Space.com even showed a radio blackout map during the X4.2 event, highlighting how the impact footprint can be regional, depending on Earth's orientation at the time. It's not evenly distributed danger, it's geometry plus timing. So if you're watching AR4366, always ask, which side of Earth is sunlit during the flare? That's where the immediate radio disruption tends to matter. The sun doesn't hit the whole planet equally at the same moment. Now, I promised you a third tell, but first I want you to experience the suspense that forecasters live with. NOAA can say, no CME signatures identified, and still stay tuned, because identification can change as new imagery arrives. That's why the smartest move is not certainty, it's conditional thinking. If CME signatures appear, then watch geomagnetic forecasts. If not, treat it as primarily flare-related radiation impacts. This if-then mindset is how you stay sane. Now let's zoom out for a second. The sun is entering one of those active eras where dramatic regions like AR4366 show up and remind everyone we're not separate from space. We live inside the sun's extended influence. And that brings the drama back. Auroras. Because auroras are the emotional payoff. They're the cinematic proof that something invisible is touching our world. When a CME connects, energy funnels into Earth's upper atmosphere and lights up the sky. But aurora risk is not guaranteed just because you saw an X-Class headline. Even Space.com stressed that many powerful flares from AR4366 haven't hurled significant solar material, and only an earlier strong flare had a CME that grazed Earth. That grazing idea matters because it teaches you humility. A near miss can still produce minor geomagnetic conditions. A direct hit can produce bigger storms. But the sun is not trying to entertain you. It's releasing energy according to physics. Okay, here's the third tell, the one most people never learn. It's not just the flare class. It's not just the CME existence. It's the magnetic orientation and solar wind conditions that decide how strongly Earth couples with what arrives. This is why two similar events can feel totally different on Earth. It's why one day you get a gorgeous aurora and another day you get nothing but a few tech hiccups and a bunch of disappointed photographers on social media. So when you watch AR4366 coverage, ignore creators who promise exact aurora dates like it's a scheduled concert. Watch the language. Possible? Glancing influences? Minor conditions? Monitoring. That's honest forecasting, not hype. Now let's make it interactive, because retention is a two-player game. If you're watching this, pause for half a second and pick your character. Are you here for the science, the auroras, or the systems impact angle like GPS and radio? Because your character choice changes what you should watch. Aurora hunters care about geomagnetic forecasts. Radio operators care about R-scale disruptions. Satellite folks care about the broader environment. One sunspot, many storylines. And AR4366 is perfect for this because it's a crossover event. Big enough for sky watchers, active enough for disruption watchers, and complex enough for science nerds. That's how a science topic turns into a viral topic, multi-audience relevance. Now I'm going to do a little psychological trick. I'll describe two futures and let your brain lean into one. Future 1, AR4366, keeps barking without major CMEs, so you get repeated radio disturbances but no giant geomagnetic storm. Future 2, AR4366 finally throws an Earth-directed CME with the right orientation, and suddenly Aurora forecasts light up, systems managers pay attention, and everyone who ignored it feels late. Same region, different outcome, different memories. The reason this keeps people watching is because uncertainty feels like a cliff edge. You want closure. But the honest closure is, Watch the official updates, watch the geometry, and don't confuse flare drama with impact certainty. Now, I'm not going to leave you with only vibes. Here's a practical ritual. If you see an X-class headline, check NOAA SWPC first. Their posts explicitly mention CME signatures or modeling when available, and they update when needed. Next, check the current space weather conditions panel and read the impact language, not just the letter number. If it says R1, note what that means for HF radio and navigation. If it escalates, you'll understand the latter. Then, and only then, go watch the excitement videos. Because if you start with hype, your brain becomes addicted to adrenaline and starts treating every alert like apocalypse. If you start with NOAA language, you stay grounded and still enjoy the drama. Let's also address the "I saw it with eclipse glasses" wave. Yes, space.com says you can see the spot with proper solar eclipse glasses or specialized solar filters, but that's not a flex, it's a safety procedure.